Right, we're on a building site in Chigwell for a developer called Weston Homes, and we thought we'd bring you along to show you what we do. Lots of people installing heat pumps nowadays, mechanical ventilation, underfloor heating, but we're integrating them. This is a great house to show you how we integrate the various products. Code 5 house, it's quite an interesting project to work on. We'll show you how we're bringing different products together and how the different products actually help each other become more efficient, how we help the building become more efficient, and how we help the developer achieve the Code 5 standard. So we'll walk around the property and show you the different things that are available. What we got here is a product made by Rehow called an hour duct. It's basically a pipe in the ground, and all the air that's entering the building is coming in through this pipe. So this pipe is at the back of the building. This will be a big stainless steel tower where all the air comes in. Air travels through this pipe. It's in the ground about 1 metre, 2 metres deep. And as the air travels through the pipe, in the summer it cools it down, and in the winter it preheats it by the ground temperature. So we've got free cooling and free heating available to us just by drawing the air through the pipe in the ground. What we're going to do is zoom around the corner. Because the plant room in this particular house is in the basement, we've also got an extract. So we'll zoom around and look at the extract. Same thing, big stainless steel tower, but this is where the air is going to come out of the building after we've taken all the energy out of it through the heat recovery systems that we'll show you in the plant room. The plant room is down here somewhere in the basement. So air in through the ground, air out through the ground and out through a tower here. Oh, we're actually in one of the bedrooms upstairs on the top floor. This is very much a building site at the moment, but it's a great time to get in and show you because some of the ceilings aren't up. We can show you what's going on in the ceiling, so on and so on. What we've got here is a manifold for the underfloor heating, standard manifold, everyone's seen manifolds, which will be hidden eventually in a cupboard, so it'll be tucked out away, no one will see it. But what we've got here, the red and blue pipes, we tie in our tower rails into the underfloor heating circuit, and we're maintaining a temperature in the buffer tank of the heat pump during the summertime, so that if the person living in the house wants to, they can keep their tower rails warm throughout the summer as well as the winter. Again, it's the most efficient way of doing it with a heat pump because the temperature of the tower rail goes up and down according to outside temperatures, which we'll come onto with the heat pump. The whole idea is, rather than running separate circuits around the building, we're running a single flow and return circuit and running everything off the manifold. In this property, we've done all of the plumbing, so not only are we doing all the plant room, we're doing all the first fix and second fix plumbing, all the flow and return pipes. All the flow and returns, because it's a Code 5, are pre-insulated pipe. The underfloor heating system in this house is specifically designed to work at low temperatures. Underfloor heating isn't underfloor heating. It does need designing properly, especially when you're connecting it to a heat pump. It makes a massive amount of difference installing the right design of underfloor heating in terms of the efficiency of the whole building. You might not think so, but it does. What we have here is a double meander underfloor heating design, specifically designed to work at low temperatures. One of the upstairs bathrooms here. I could go through the bathroom, tower rail down there connected to the manifold of the underfloor heating, so you can control whether you want the tower rail on in the summer or not. In the winter it will come on like the underfloor. As it gets colder outside it will get warmer. This is the way it works. Toilets, when they eventually turn up, supplied by the rainwater harvesting tank, which is outside where we started. Code 5 house needs to generate its own power. What this property has is solar PV panels on the roof. We've got 2 inverters here. The reason there's 2 inverters on the wall because we've got different panels facing different directions So to get the most out of them, we need to put different inverters on. Again, solar panels really aren't part of the integrated system, but they do form an important part of a Code 5 house, especially because they need to generate energy as well as use it. So in the plant room, my pointer is a pre-insulated pipe that's gone all around the building. Keep the heat losses as low as possible in the flow and return, so all the pipe that we've installed throughout came off a roll with pre-insulation. Small plant room, a bit tight, but we'll try and see what we can show you. Ground source heat pump here. Ground source heat pump here. Dimplex. Keep going down, going down, going down. We've got the buffer tank at the bottom. 100 litre buffer tank. And up. And we've got 400 litre hot water cylinder. We come across to this side. Mechanical ventilation heat recovery. This one feeds the basement, and if we come across to the other side of the plant room, this one feeds the two upstairs floors. Come across to the back of the plant room, the pointer. The inlet tower that we spoke about earlier, that's where it's coming into the building, through the basement wall. We split between the two and go into each of the heat recovery systems, and that's the air extract vent there. So air in, split between the two systems, air out, water. Flow and return, as well as the rainwater tank, feeding upstairs toilets, feeding the washing machine, feeding the outside tap irrigation. Property also got two grey water systems. Here's one. The water's coming from the showers, stored in this tank, and that's used to flush the toilet. So, grey water for two of the toilets, rainwater for the other two toilets. Let's try and summarise what we've got here. Again, we're trying to give you a whole picture of a whole house solution. Ground source heat pump with a single 145 metre borehole. Doing all the heating and hot water. We've got mechanical ventilation and heat recovery connected to a pipe in the ground that's both heating the incoming air in winter and cooling the incoming air in summer. We've got an underfloor heating systems designed to work at the lowest temperatures possible, which helps the efficiencies of the heat pump. We've got a cooling coil connected to the inlet duct of the ventilation system to help further reduce the cooling in the property. We've got electronic dampers in the ventilation system which open and close, so we have a form of controlled air movement in specific rooms. So particular rooms can be cooled more than others by simply blowing more air into that room. We've got a whole house plumbing system with pre-insulated pipe going around the whole building. A fully integrated renewables package that will make this house very efficient and work well with all the insulation and triple glazing and everything else that goes into a hotel house.